Assalamu alaikum everyone. I am Sumayita Shimu. Today I am going to talk about support vector machine, also abbreviated as SVM, a powerful machine learning algorithm. So what is SVM? SVM is a supervised machine learning algorithm. It is used for both classification and regression tasks. The key idea behind SVM is to find the best decision boundary, also known as hyperplane, that separates data into different classes. Let's go to dive into know some terminologies that you will encounter while working with SVM. First one is hyperplane. Hyperplane is a best decision boundary that separates data points into different classes. Margin is the difference between the hyperplane and the closest data points. Support vectors are the closest data points to the hyperplane. Hard margin classifies the different data points into different classes, but it doesn't allow any misclassification. On the other hand, soft margin also allows some misclassification. Kernel. It is the most important topic in case of a SVM. Kernel is a function that maps the data points into higher dimensional space. C is basically a regularization parameter. So how SVM works? SVM chooses the hyperplane that best separates the classes and maximizes the margin. It can handle both linear and non-linear separations, but in case of a non-linear, it uses the concept of kernels that we will see later. This figure shows a multiple hyperplanes separates data from two different classes. Here we can see that there are two groups of data. First one is blue one and the second one is red one. And there are three hyperplanes. So which one is to choose? The key idea behind SVM is to find the best hyperplane that maximizes the margin. The margin is the distance between the margin is the difference between the hyperplane and the closest data points. So in case of this figure, we'll choose L2 as the hyperplane because this maximizes the margin between the hyperplane and the data point. So how does SVM classifies the data? SVM classifies the data by finding the most optimized hyperplane that best separates the data points from different classes. Here are two different groups. One is blue one and the other one is red one. Here is a one data point which one is from blue one. Blue one blue one in this case is an outlier in the case of a red data points. So SVM, in case of SVM has a characteristics that ignores the outliers. So in this case, SVM ignored these data point and separate this is two classes into two different classes. What to do if data are not linearly separable? So it is not always the case that the data are linearly separable. That is, we can separate the data points by using a straight line. There is some cases where that we cannot separate the data points into by using a straight line. When data is not linearly separable, SVM uses a technique called kernel. So as we know earlier that kernel is a function that maps the data points into higher dimensional space. Here we can see a one-dimensional data set that is used for classification. In case of we can see that in this data set there are two groups. One is blue one and the other one is red one. But we cannot separate these data points by using one straight line. In this case, we will use the concept of kernel. Kernel will represent this as data points into higher dimensional space. Then we can use a straight line and separate the data points into two different groups. It suggests that SVM maps the lower dimensional data points into higher dimensional space that is more visible. SVM supports these types of kernels. One is linear kernel, polynomial kernel, RBF kernel, and also known as sigmoid kernel. Polynomial kernel and RBF kernel, this is also known as a radial basis function. And these kernels are used for non-linear data points, and linear kernel is used for linear classification. And sigmoid point is similar to the activation function in case of a neural network. This is the representation of mathematical computation in case of a SVM. We can represent the hyperplane in case of a SVM using the equation Wx plus b equals 0, where W is the weight vector, X is the feature vector of a data point, B is the bias term. Types of SVM. Basically, there are two types of SVM. One is linear SVM and the other is non-linear SVM. Linear SVM is used when data is linearly separable. That is, we can separate the data points by using a straight line. And non-linear SVM is used when data is not linearly separable. That is, we cannot separate the data points by using a straight line. In this case, we use the concept of kernel. There are several advantages of SVM. Among them, some of these are it works well in case of higher dimensional space. It is memory efficient. It is both versatile with the choice of kernels. That is, can work both with linearly separable data and non-linearly separable data. There are several disadvantages of SVM, like it is not suitable for large data set. Those who are working with large data sets, yeah, it will work very slow on training. It is sensitive to noise. In the choice of a kernel, parameters can impact the performance. Like if we choose a linear kernel, in case of a non-linearly separable data, it will not perform so well. And there are several applications of SVM. Among them, some of these are face detection, text and hypertext categorization, image classification. In case of a bioinformatics, it can use as a cancer classification. In conclusion, we can say that SVM is a powerful and versatile machine learning tool. It is based for small to medium sized and well-level data sets, but it does not work so well in case of a large data set. The choice of kernel and the tuning become crucial to its success. This is all about my presentation. Thank you all.